It is not straightforward to apply other field concepts to magnetic fields. Because magnets exist as dipoles, we cannot have a simple radial field. Instead, we must always have a field line going from a north pole to a south pole. Properties of fields such as field strength and potential are not as straightforward because of this. Field lines in a magnetic field are approximate to magnetic flux, but are not the same. Magnetic flux is a number of field lines passing through a given area at any one time. More than that, the area the field lines pass through has to be perpendicular to the direction of the magnetic field lines. If it isn't perpendicular, then an amount cos theta, where theta is the angle between the field and the area, is taken. It is because the field lines are connected to a form of charge, poles, at both ends, that we call this flux to make the difference from other fields. Magnetic flux density is the concentration of flux within an area and is given the symbol B. It is approximately the same as the field strength, but contains flux lines instead of field lines, so is called flux density. Magnetic flux density has the unit of a Tesla, although 1 Tesla is a very large unit. 1 Tesla of magnetic flux density is equal to 1 Newton of force acting on a charge of 1 Coulomb moving at 1 meter per second perpendicular to a magnetic field. In a current carrying wire, the Tesla can be defined as a force of 1 Newton divided by a current of 1 amp in a wire of 1 meter within the magnetic field. The force on a current carrying wire is equal to the magnetic flux density times by the current in the wire times by the length of the wire in the magnetic field.